Hi friends, I'm Ramya. Today our topic is on graphs. In coming topics of motion in a straight line, we will encounter with graphs. That is why it is need to study about graphs, especially in physics. For this, today I will discuss commonly used graphs, and by using these graphs one can easily tell the variation of physical quantities. Physical quantities means position, velocity, displacement, distance, acceleration. All these are physical quantities. By using graphs, one can easily tell the variation between them. Graphical representation means it is the efficient way of visually representing a vast amount of information about the motion of an object in a conveniently small space. The representation of vast amount of information in small space is nothing but graphs. In this chapter, we will confine our study to only rectilinear motion, means which is nothing but the motion in a straight line. Here, I also represented only straight lines because we are confining our study in motion in a straight line only up to rectilinear motion. Here, we are taking x-axis and y-axis, x-axis and y-axis. And if the variation of a physical quantity means if we take position on y-axis and time on x-axis, if the variation of a physical quantity on y-axis is changing with respect to another quantity which is on x-axis is linear means the position, if we take position on y-axis and time on x-axis, the position is changing with respect to time, which is linear here. The change is linear, and it can be written as y is equal to mx plus c, which is the general equation of straight line. That is y is equal to mx plus c. By using this equation, one can represent the change in position of that physical quantities is linear. And here m is nothing but slope and c is the intercept of that particular line. Slope, in another word, it is a gradient. Slope of a line or gradient of a line is a number that describes both the direction and steepness. That describes this slope. It gives a number which describes the direction and steepness of that line. Slope of any line remains constant along the line, and the slope can be calculated either by looking at the graph or by using the coordinates. This is the coordinate system. By using the coordinates of any 2 points on a line, by using the coordinates of any 2 points on the line, we can tell the slope. By seeing graph itself, we can tell the slope. Here the slope is positive and here the slope is negative because it is rising. It travels from left to right and it is rising. Here it is decreasing. That is why we can easily tell by seeing graph slope is negative here, slope is positive here, and there is no slant of this line. It is horizontal line. That is why there is no slope here. M is equal to 0. And intercept means the intercept of a line is the point at which it crosses either x-axis or y-axis. Here it is crossing y-axis. At this particular point it crossing y-axis. If we do not specify which one means x-axis or y-axis, you can take, or one can take, the intercept of a line is on the y-axis. The intercept of a line is y value of the point where it crosses, in the y-axis. Here C we are taking as intercept. It crosses y-axis. That particular point where it crosses on y-axis is nothing but intercept. And another thing is the common formula used for slope are slope is equal to y2 minus y1 by x2 minus x1. Our m is slope, or we are taking coordinates also x1 y1 x2 y2. This is change in y-axis and this is change in x-axis. And another formula is tan theta is equal to slope. Tan theta is equal to slope, which is nothing but change in y-axis by change in x-axis. If we take position here, if we take time here, change in position is nothing but displacement, and change in time, displacement by time, is nothing but velocity. By calculating slope, you can get the physical quantity, and it is defined as the ratio of change in the y coordinate to the change in the x coordinate, since it gives us the dimensions of perpendicular and base of right angle triangle. It is the ratio of perpendicular, this is perpendicular to this line, the ratio of perpendicular and base of a right angle triangle is equal to tan theta. Here, if we consider an angle theta by a horizontal and a slanted line in this illustration, that angle can be specified. This angle can be specified by just giving its slope. By just giving its slope, we can specify this angle, that is slope is equal to h by b, is nothing but the length of the opposite side by length of the adjacent side, which is nothing but tan theta. Here theta is the one of the acute angle. It may be 30 degrees, 40 degrees, 50 degrees, up to 90 degrees, means an angle whose measure is more than 0 degrees but less than 90 degrees is nothing but an acute angle. Here the angle can be specified by using the slope. This ratio in geometry is referred to as tangent. So slope of a straight line is the tangent. Slope of this straight line, this is the slope. Slope of this straight line is nothing but tangent of its inclination. Tangent of its inclination. Inclination means valu or vampu, is nothing but tangent. Here angle of inclination of a line is the angle formed by the intersection of the line at the x-axis. Here angle of inclination of a line is the angle formed by the intersection of the line, angle formed by the intersection of the line and the x-axis. This angle is formed by the intersection of this line and the x-axis. Here now change in y over change in x is nothing but change in y over change in x is nothing but tan theta from the right angle triangle. Now we will discuss some example graphs with different slopes and different intercepts, particular intercept values of a line. If you see here in the first example, slope m is greater than 0 and C, intercept of that particular line, is also greater than 0. Here the straight line equation, we know that y is equal to mx plus c, where c is the intercept, or we can, in place of c we can keep b also. Both are same. Y is equal to mx plus c is the straight line equation. Here the intercept is 3, because at this point only this line is crossing this y-axis. So here the coordinates we are taking is x1, x2, y1, y2. If we apply slope formula m is equal to y2 minus y1 by x2 minus x1, you will get positive 2 value. This y by x is also nothing but tan theta. This change in y by change in x perpendicular by s is nothing but tan theta. Here angles are measured relative to the positive x-axis. Angles are measured relative to the positive x-axis, and that positive angles take you into the positive y-axis, positive y direction. Here the angles are measured relative to the positive x-axis, and these positive angles take you up to the positive y direction, which is nothing but anti-clockwise system of angles. Here angle theta is in anti-clockwise direction, starting from positive x-axis. Here theta is in between 0 to 90 degrees. The value of tan theta is positive. So slope of the line is positive. On any point on the line you can take slope. Here also you can take like this. Here the angle is in between 0 and 90 degrees. The value of tan theta is positive. Already we did this. 2. Positive slope means with increase in the value of x, the value of y will increase. Positive slope means if x value increases, y value also increases. If x value decrease, y value will decrease. Both are related to each other. If suppose slope is negative, means theta is in between 90 degrees to 180 degrees. 90 degrees to 180 degrees means it is an obtuse angle because more than 90 degrees. Here in this case, if we increase in x value, the value of y will decrease. If increase in x value, the value of y will decrease. But here positive slope, that is increase in the x value, the y value also increase. In another example, here positive slope means the line is going from left to right and it is rising. This is the representation of positive slope. By seeing graph itself, we can tell the slope, that is which is nothing but positive. And if we take slope is less than 0, and see intercept is greater than 0, in this case the graph will looks like this. Here theta slope is less than 0 and intercept is greater than 0. Intercept, here it is the intercept point. Here the angle is more than 90 degrees. Here this is perpendicular, this is 90 degrees. More than 90 degrees, this line is taking angle with x-axis. Here slope is negative, means x is increasing but y is decreasing. In this case, it is an obtuse angle in the anti-clockwise direction with the x-axis. And in another words also we can tell that an acute angle, acute means its angle is between 0 to 90 degrees, not more than 90 degrees. If angle is more than 90 degrees, which is nothing but obtuse angle. In other words, an acute angle in the clockwise direction. Clockwise direction means here we are placing negative. Clockwise direction with the x-axis. Like this also we can tell, our anti-clockwise direction with x-axis. In this case, if we take theta is equal to 135 degrees, we will get the slope as -1, means negative slope we will get. That is why here If even though x is increasing, y is decreasing. Negative slope means the graph will be like this. It is falling. It travels from left to right, but it is falling. If we take this example, here slope is 0. Slope is 0 and intercept value is greater than 0. If slope is 0, the graph will looks like this. It is a horizontal line. If we take an example like this, the intercept point is 4 and the coordinates we are taking as 0, 4, 0, x-axis 0 and y-axis 4, because the line is on y-axis. That is why x value is 0. X 0 and y 4 and x2 means here x2 3. This point is on this line, y-axis line. That is why if point is on y-axis, the x value is 0. That is why we are taking 0 and 4 in y place, and in x2 y2 we are taking 3 in x coordinate x2 and 4 for y2. If we do the same thing as we did in above example, slope is equal to y2 minus y1 by x2 minus x1, we will get slope 0. If you place these values in this, you will get slope 0 and intercept is 4. For slope 0 graphs, it looks like this. In another example, here slope is greater than 0 and intercept is less than 0. Intercept is in negative side. The graph will be looks like this. If intercept in negative side and slope is greater than 0, that graph will looks like this. And in this case, if slope is less than 0 and intercept is also less than 0, the graph will be like this. The slope is less than 0 and intercept is less than 0. Then the graph will looks like this. The angle here is more than 90 degrees. More than 90 degrees means obtuse angle, which is negative. Then for obtuse angles, the slope we will get is negative. These are the small examples about graphs. Thanks for watching.